Welcome to the first of what I'm going to call an identity break. In identity breaks, we'll take a look at new functions and discuss some essential identities when it comes to manipulating them. For this first identity break, we'll be going over the hypotenuse function. On each slide, we'll figure out our identities by starting with a definition of hype. As our first example, we'll notice the absolute value signs around each of our variables, with no other negative signs being added or multiplied. This gives the result that height base p of x is greater than or equal to 0 for all real numbers p and for all complex numbers x. For what we'll be concerned with, though, it's enough to know that height is positive for all positive p and all real numbers x. Next, if you plug in a negative x, you'll see that the negatives will disappear, leaving you with height of x. This means that height of negative x equals height of x. Here's a visualization of this identity. The length of the solid blue line is the same as the length of the dotted green line when they're at opposite angles. You can also think about this identity and identities to come in terms of a squircle's symmetry. A squircle can be divided into 8 identical parts, with one of them being a curve between the angles 0 and pi/4 radians. For our next identity, we'll be looking for periodicity. If we add pi/2 to the argument, we'll see that our cosine becomes negative sine and the sine becomes a cosine. Due to the commutativity of addition, we can see that this is the same as height base p of x. By repeating the addition of pi/2's in the argument, we get the result that height base p of x plus pi/2k equals height base p of x for all integers k. In other words, no matter how many pi/2's you add or subtract from the argument of height base p, it's the same as height base p. Here's a visualization of this identity, with the solid blue line being height of theta and the dotted green lines having the same length as the blue one when they're offset by integer multiples of pi/2. Finally, we have another reflection identity, this time about pi/4. Making our argument pi/2 minus x, the trig functions end up swapping places, resulting in height base p of x yet again. Here's the same type of visualization as with the previous two identities. We can derive a stronger version of this identity using the previous two. First, since height is periodic with all integer multiples of pi/2, we can negate the pi/2 and the statement remains true. Then, taking the fact that height is an even function, we can negate the argument and see that height is reflective about any integer multiple of pi/4, not just pi/4. Here's a full visualization of the stronger reflective identity. This identity truly takes advantage of the squircle symmetry. You can see that even though the blue and green are moving in opposite directions, they still have the same length. So to recap, we learned that the hypotenuse function is always positive, is even, is periodic for pi/2, and is the same when it's reflected across multiples of pi/4. These are some really good identities, especially when working with the other base p trig functions, because it means that multiplying by hype doesn't change whether positive or negative. We'll see more of what I'm talking about in future videos. See you in the next one!